Hello, friends of Herbie. Welcome to this new episode of the Campfire Talks with Herbie. In this episode, we will have somebody who is very skilled at test-driven development, and that brings back fond memories of mine. As you might know, once upon a time, in the previous millennium, in the Stone Age of this industry, I was also fiddling around with coding and software engineering. So I am very curious to listen to our guest. And our guest is none other than Mr. Jbrains. Welcome.
Hi, thanks very much for having me.
It's a great pleasure to have you here. And as usual in our show, we will start off with an interview, and then we'll go on into some more interesting things. So to begin with, now, who are you, Jbrains?
Yeah, so I'm, as I like to say, I'm an agile coach, but actually agile and actually a coach, which is funny for marketing, but really what that means is I'm an old extreme programming guy. I got my start with the old extreme programming crowd in the very late 90s, early 2000s, at the beginning of my programming career, and that really influenced how I worked and how I continue to work, and indeed even how I live. If it weren't for those folks, I would probably still be living in Toronto right now, working as a middle manager somewhere at IBM, and be ready for my first heart attack. But instead, I live here in Atlantic Canada and live a leaner, more relaxed lifestyle, travel more, and during years when we don't have a pandemic, I get to spend 3 months of the year wandering around Central Europe trying to help other people get the same benefits from lightweight software development approaches that I've managed to get over the last 20 years.
Whereabouts in Canada are you exactly?
I'm on Prince Edward Island, so we're, I don't know, several hundred kilometers northeast of Boston. If you draw a line from the very tip of Maine east, you hit us. So we're not quite in the Atlantic Ocean. We still have Newfoundland in the way between us and the Atlantic Ocean, but we're Atlantic Ocean adjacent.
Well, you know that we have Montreal, which is like a stronghold of TameFlow. Daniel Doiron is there, and many others. So Canada is really an early adopter and strong adopter of TameFlow. And you know, I love it what you said, that you started off with XP in late 90s. I also was one who introduced XP in Sweden in 1999, if I remember correctly. In some companies, they all thought we were crazy. But okay. So how did you get involved in this agile space, or what shall we call it?
It's interesting that you asked, that throwaway, what should we call it? So I've been, this could be an entire 2-hour discussion on its own, but it won't be. I've started trying to deal with the fact that there's a bit of a problem with the word agile in the general software development world. There are a lot of people who have been soured on it as a result of some bad experiences. Whether they were well-meaning or cynical doesn't really matter. They were bad experiences, and that has led people to not like the word agile in some quarters. So I've started trying to remember what was it about agile that I cared about in the first place. And what was really interesting to me at the time was some combination of lightweight and feedback focused. And so I like to talk about lightweight approaches to software development in general, and it just so happens that extreme programming is probably the thing that I'm the most familiar with, the one that I have, the one that was the most influential to me at the beginning of my career, which is why my agile or my lightweight is very XP. Let's say it's XP shaped as opposed to say FDD shaped or DSDM shaped or any of the other. Had I been in a different part of the world 20 years ago, then I might very well be a hardcore FDD advocate or DSDM advocate. But because I was in Toronto in the late 90s and early 2000s, I happen to be surrounded by a lot of folks in the extreme programming community, and that, I found them, oddly enough, through being a terrible programmer. I was one of those people who had lots of capacity and not a lot of ability. Strong capacity to think, but not a lot of discipline about how to think and to do well. And I remember being stuck in that point where you sort of, you fix one bug, create two more, fix two bugs, create one more. And it just seemed like I was going around this hamster wheel, and the finish line would be running away from me as quickly as I was running towards it. So one day I opened up altavista.com and I typed into the search bar, how to test Java code. And from there I found JUnit. And from there I found an early draft review of the book Extreme Programming Installed, which is the second XP book, the pink book. And, most people, when they read about extreme programming for the first time, they either think it's perfectly logical, reasonable, love it, and want to dive in, and others who react by thinking, this is nuts, nobody should try to do this will never work. I was in the first category. I jumped into it right away, started learning about test-first programming, and 20 years later, I'm here on this show talking to you.
Yeah, very interesting. I was also involved in the TDD world once upon a time. I went out of programming to start this other career in let's call it management consulting. But I was very engaged in the creation of DUnit, the Delphi unit, or Delphi, as you would say on that side of the pond. And later, I was fiddling around with Ruby on Rails, and I think I did one critical correction to the what was it, RSpec, the RSpec BDD framework. So I can relate to what you're saying. But hey, I see on your shirt you're having like something professional there. Oh, maybe now we don't see it. So let's bring this up. Oh yes, that's put your chest forward.
Also,
so people can find you or find out about you at this webplace, www.jbrains.ca, and note that it's .ca, not .com as most of the websites, because you had another one with that name already taken, right?
Yes, somebody's taken it, so I got to make the Canadian part of my identity a little bit more prominent there.
Okay, that's great. And obviously with this, you are a professional in the field, so you're making a living here, and how does that look like? And have you ever looked at TameFlow at all?
I'll be frank, I have not. And actually, I didn't want to do too much. I didn't want to do too much research here because I didn't want to anchor myself. I wanted to see what I would have to learn from you here this evening, or this afternoon.
Okay.
So most of what I do amounts to people know me as a test-driven development guy, a JUnit guy, depending on how far back they go, if they know me at all. What that usually means is that my entry point into companies tends to be focused around either we think something like test-driven development would be helpful, but we don't do it at all, or we've been trying to do some kind of testing, maybe some kind of test-driven development, maybe just some kind of unit testing, and we're struggling with it, and we'd like some help. Like, what are we doing wrong? What are we missing? Earlier in my career, it seemed to be there were a bunch of people who decided to try to do test-first programming, or even just back then we talked about programmer testing or developer testing, sort of the idea of testing that programmers do for themselves as opposed to testing that maybe testers do or that other parts of the organization do to critique the programmer's work. But at some point, in the mid 2000s, I think it started to become quite mainstream for programmers to be expected to do non-trivial amounts of testing for themselves. And they would typically run into the problem of an exponential growth curve in the cost of running their tests. And that led, trying to deal with that problem and trying to help them through it led me to at first trying to talk about how do you do test-driven development in, say, enterprise Java or in any of these very heavyweight software environments. And eventually that led to one of my relatively famous contributions, integrated tests are a scam, which is one of those, again, marketing forward joke titles. But every good joke has a kernel of truth to it. And the integrated test scam essentially says that, most programmers, when they try to do unit testing, they run into this problem where their tests pass, but they still find bugs. And part of the reason that they find bugs is that it's impossible to test out all bugs. And the specific bugs that they find usually tend to be in the communication between parts of the system, whether it's at the level of tiny code modules or at the level of, say, subsystems that are separated by networks, whatever it is. There's one part, one side of the conversation thinks it's going to go one way. The other side of the conversation thinks it's going to go another way. And because there's this incompatibility between the two, the tests for each individual part could be correct and pass. But when you put them together, they don't work. I expect you to return an empty list. You're going to return null instead. And then we have an integration problem. And most programmers think that if they write bigger tests that test bigger parts of the system, that they will be able to detect and correct that problem. And if they do that a little bit, that can help. But if they do that enough, eventually they reach the point where the cost of maintaining those tests far outweighs the benefit they get from them. But then they fall into the trap of thinking, well, if a little bit of testing is good, then a lot of testing must be better. And before they realize even what's happened, they now have test suites that take 24 hours to run. And the number one thing that they were getting from their tests, which was feedback, they're no longer getting that feedback anymore. And yet they insist on writing more tests, actually making the problem worse.
So it's like going back to punch cards in a way.
It starts to feel like it. I mean, at some point, you might as well just, it almost would be better to fly somebody across the country to type something into the computer over there and come back. That would be somehow faster than what we're doing. Yeah. And so that's something that that was where I got very much into this micro testing, tiny pieces style of testing and design. And I'm still doing that today. That ends up being a starting point for a lot of discussions with programmers.
We'll get back into some examples of that later. But I want to mention one thing here because it draws like a nice connection between your work and the mysterious world of TameFlow, because TameFlow is inspired in many ways by the theory of constraints of Dr. Goldratt. And I know you have written an amazing article a while ago trying to justify or explain what is the reason why should we do test-driven development. And you sort of explained it in terms of TOC. Can you sum up that? And in the meantime, I'll just show here to the audience that you can find this article here, tdd-and toc.jbrains.ca.
Yeah, and justify is the right word. I mean, I early in my career, my biggest struggle seemed to be encouraging people to try test-driven development. I had every reason to believe it would help them. If I watched them work for a while, I could see how it would help them. Just having 5 years more experience than they had in that direction was enough for me to see how it would help. And even more than that, I mean, later on, I started to see really how test-driven development is not just a technique for testing or for being a better disciplined programmer or any of that stuff, but indeed it can be used as a technique for learning and deeply understanding the principles of design, sort of in the same way that a person learns to speak a different language. I noticed all these latent benefits of test-driven development, and there were a bunch of programmers who were just not willing to try it. Either they were waving it away completely, or they would only try it under threat of firing from their manager. And I thought, wouldn't it be nice if I could provide people with an explanation and accounting of how test-driven development could possibly work using something like theory of constraints, where maybe it's a little bit harder to argue with the theory, where the theory is a little bit more self-evident, And so as a result, what that really means is that instead of trying to convince people that I'm right, if I can appeal to them with something that they are more likely to believe and more likely to believe in, more likely to accept, then it might help them just get started. And when I came across this idea from queuing theory in my reading of, my early reading of theory of constraints, I thought, aha, this is not only is this a candidate that people will believe in, but when I show people that I can turn Winston Royce's waterfall diagram into the classic diagram that's now on the test-driven development groups.io page of the big concentric feedback cycles, if I can show them that, like that became a talk that everybody loved. I did that for 2 or 3 years at meetup groups, at conferences, and then finally I thought, well, when I write this down, this is going to make an impact. And I don't know what kind of impact it had, but I do occasionally get people who come up to me at conferences or if I'm working in companies and say, this was an article that actually did help me feel comfortable giving this stuff a shot. So it seems to work for at least a non-trivial number of people.
Great. So let's see if we have some comments here. Some people are entering. When we have 3 from Roster. Hello all. We have Anna from Montreal. Hello from Montreal. We have, of course, Daniel, who is the co-author of my book. And he has a comment here. He has a comment here. Don't know what he's referring to, but no, it's nice. Let people work is a big thing with TameFlow. When coworkers see others pair programming, they hesitate before interrupting. A nice variation on let people work. Okay, we have Mikhail Kusters from Germany. He's waving. Minton from New York. Comment from Daniel. I carried my code. The sound of a car shuffling scares me no end. Yeah,
I carry my code too, except that I carry it in here now instead of instead of in cards.
Testing shows the presence of bugs, but never shows their absence. Dijkstra, yes. We have Mikhail. Yes, Mikhail is saying something. No, wait, where is it? There. Ever tried TDD in shell?
Yes. I was shocked. I had a problem with redirections not working for one of my websites. I'd set up a whole bunch of these nice vanity URLs using a DNS service, and then suddenly links started failing. And I thought, well, I should at least have some automated tests for this. So I found shunit 2, which allows you to, is a simple XUnit clone written for, I guess, for any shell. And I used it in Bash to first to do some testing to help me find some mistakes. And then so that's really less test-driven development and more test-first programming. Now, if I want to change how domain names map to links, I go to those tests first, and I wait for a failing test before I go into DN simple and change a DNS record.
Okay. And finally, we have Rudiger. Hello from the UK. Okay, so you told us a bit about your background and story, but how is a typical normal day in your life?
Well, it depends what time of year. So when we don't have a global travel disruption, then for the last 10 years from mid-September to mid-December, I've been mostly in Central Europe, visiting clients, speaking at conferences, offering open training courses. Home for the previous 4 years had been Stockholm, but I'd also spent a lot of time in the Vienna, Bratislava area. And that's where I do almost all my on-site work. Unfortunately, Canadian clients don't seem to be interested in hiring me because I'm not the exotic foreigner the way that I am in Central Europe. So that's where I get a chance to work with clients. And generally speaking, it's either I'm there to do some introductory training, or I'm there to help with, to find out what teams are doing And my normal mode of work seems to be that I sit down with a programmer or a group of programmers to start working on a programming problem. And after 2 hours of trying to write tests or trying to do test-driven development, we start hitting some kind of roadblock. And as I'm asking questions about why these roadblocks are here, suddenly we uncover a whole bunch of other problems, some of which are, organizational structure problems, some of which are interpersonal communication problems, some of which are personal productivity habit problems. And then suddenly we notice that we're talking about those things instead of just design and testing and writing code and making technology talk to each other.
But what makes you happy at the end of such a day?
If I feel happy at the end of the day, it's that I get to see a little bit of the relief on some other person's face, that there's something they learned that day that starting the next day is going to make their life easier, whether it's their life away from work or their life at their job, that they learned some trick that's going to save them a minute here, a minute there, that they understand something that didn't quite fit in their brain before, or even just that they get confirmation from somebody with 10 years more experience, 20 years more experience, that some of the dysfunction that goes on around them is common, maybe in some ways unavoidable, and that they don't have to feel responsible for letting that go on. They're not necessarily enabling it, and they're but they also need to learn how to live with it. And if I can help them feel less stress at the end of the day, if I see shoulders looking more relaxed, a slight smile on somebody's face, then that's more than enough for me. I mean, test-driven development isn't for me, some kind of moral judgment about how professional you are as a programmer. There's only one useful definition of professional, which is, did you get paid? I'm interested in these techniques because they helped me feel better about the work that I did, so I could bring more of my own energy to that work. And that made me feel better about the work that I was doing, made me feel better about my jobs, made me delayed the point where I got fed up and decided to quit, any of those things. If I can bring that to more people, then that's the kind of thing that makes it worth it for me to then travel away from home for 3 or 4 months a year, or to figure out how to try to bring these ideas to more people during this difficult time where this is the only way we can talk to each other.
And in this career, was there any special insights or skills that you have picked up or developed?
Yeah, one thing, there were a couple of things that happened quite by accident early in my career that made a big difference. One was that I spent a year working as a technology trainer, like teaching people boring stuff like how to do WebSphere administration and all kinds of crazy stuff like that. And just the act of being in front of a classroom 20 weeks out of the year gave me a very quick idea of what it is that actually helps people learn and what doesn't help people learn, how to build a training course and how not to. So that helped me both in bringing some of my ideas to, larger groups of people, but it also is now one of the things that I help other people do. Part of my consulting is helping people learn how to do training, because training is a nice, convenient thing to offer as a consultant. So that was one. Another was I spent sometimes 6 hours a day hanging out on the old Yahoo groups, test-driven development, refactoring, extreme programming, the early Scrum groups. And what that did was sort of that, not only that gave me a chance to connect with the couple of hundred people in the world who were the most experienced at this stuff, at this emerging field, but man, did I practice asking and answering questions and finding out what answers helped people and what answers didn't, and finding out, sharpening my ability to reason, sharpening my ability to argue in the nicest way, sharpening my ability to explain. And so that really helped me, because if you're going to give advice on anything, you're probably going to need to explain why you believe your advice is going to be helpful. And so in the beginning, that really helped me, that I really wasn't prepared for how important that was going to be. But the big thing was just recognizing that having the best answer is not necessarily going to help you influence other people. And so about 6 or 7 years into my career, after banging my head against the wall, me having all the right answers but nobody listening to me, that's when I started to understand that perhaps the way that I described things to people, the way that I talked to them, the way that I related to them was as important or more important than having lots of good ideas. And that has led me up to this point where, yes, talking about programming issues is the way that the conversation usually starts. But it doesn't take very long until we're at the point where we're talking about all the other things that go into how do you influence people? How do you work with people? How do you treat people?
So it's
how do you encourage them to treat you differently?
At the end of the day.
Oh yeah, I mean, I read Peopleware not that long after it first came out, and I laughed at a few interesting things in there, but it wasn't until I read that book again about 10 years later that I really appreciated how important that stuff was. And I think getting grayer probably helps with that.
Oh, that helps with many things.
Gradually you realize somewhere close to 40 that stuff really matters.
It helps forgetting things as well. So.
Yeah, well, relearning stuff can also be good.
Okay. So we have another comment. I think this was triggered by Miko's TDD in a shell. CGTNet says, I had sort of a Zen moment once when I realized that I can inject test doubles into shell scripts by changing the $path variable.
Yeah.
Wow. A Zen moment in that way. That's amazing.
It's nice. It's, moving details up the call stack is one of the 5 programming tricks I have. And that's a perfect example of that. Part of the environment variables are there so that scripts don't have to know what those details are. You're pushing the detail up the call stack. It's no different doing it in the shell than doing it in C#.
So it's a sort of abstracting mechanism.
Absolutely. Pushing details up just means that all the abstractions you need settle down gently and carefully to the part of the system where you need them.
Okay, we have Leipas.
Aha, hey.
From Laura and Tobbe.
Mina vänner i Stockholm. Our apartment in downtown Stockholm is literally around the corner from them.
Välkomna.
Absolutely.
Okay, so what are some of the greatest challenges on developing your profession, and how do you see these challenges? Not only those that you've had, but those that you think you will have to face. What are they?
Personally, my biggest challenge is really just the not really understanding how to commoditize the things that I want to teach. Like, it was very easy with test-driven development. It's a very concrete concept. Programming topics are very concrete. It's very easy to learn how to turn that into things that you can teach and sell as a commodity in a way to help people understand how to buy from you. And I struggle a little bit with, once you get into topics that go beyond programming, it's much more complex. It's very hard to distill that down to single articles or to a 2-day training class. But the community I live in, still, the Agile community, for better or worse, I think the biggest struggle that they face right now is that I shouldn't distance myself from it. We went through a period where a lot of the stuff that we tried to teach people got away from us. And we didn't know how to handle it. We didn't know how to help people use these tools and techniques effectively. And I should say, not enough of us knew well enough how to do that. And what that ended up with was a whole bunch of people who did things that they call Agile that really were never going to change anything. And the blowback is that now we've lost a lot of trust, and earning that trust back is going to be difficult. And some people are trying to earn that trust back by running away from the word Agile and trying to essentially do the same things under different brands, hoping that nobody notices. Some others, maybe like me, stubbornly want to rehabilitate the brand and to show people, no, that's not what we meant. We meant this. You'd mentioned before we started talking today about having spent some time in the Rails world, and I remember exactly a similar thing happening there, where it took several years for the Rails community to realize that maybe being able to test smaller parts of the system independently from each other could be helpful. There was a part of me that sort of had to chuckle and think, well, it took them 3 to 5 years to figure out that this stuff that we've been talking about could actually help them. And early in my career, I probably felt very self-satisfied about that in a negative way. Like, okay, you people, how stupid are you for taking 5 years to figure out that I was right all along? I think there's still a lot of that in our community. What I'd like to see us move is more in the direction of the model I think of as sort of the wise grandparent in the corner, just calmly rocking back in a chair, watching the children play around and get into fights and hurt each other and make mistakes and get cuts and scrapes on their knee, and insist that they'll be able to figure it all out. When they're ready for some sage advice, then we'll be there, not only with good advice, but also with a shoulder for them to cry on. I think that we're really going to need to show this community, whom we've caused to mistrust us, we have to show them considerable compassion. That when they're ready to take seriously concepts like feedback, like simplicity, like frequent delivery, closing the feedback loop in the entire business, not just within software delivery, that when they're ready to do that and they're not sure how to get started, that we look at that as an opportunity to say, there, I know, I had to learn the hard way too, I'm ready to help you, as opposed to, hey, you idiots, what took you so long?
So, Grandpa Jbrains, after all these challenges you mentioned, but you must have had some good rewards as well. And what's more rewards do you want to have from this profession?
I certainly had some great rewards. I've seen people that I worked with who were even some of my strongest adversaries in the very beginning, become important parts of our community. And not just because that in itself is important. That's just a signal that I was able to show them something, expose them to something that helped them, that helped improve their lives in a non-trivial way, and that they went on to do more of what they wanted to do with less stress, with better results. And that I was able to help make that happen, whether it was helping somebody finally build the courage to quit a bad situation, or helping somebody join our community and become an emerging leader in the same way that the people before me helped me to do, I've been able to do for other people. And so I find that rewarding, that, I'm not just sitting here with a bunch of good ideas and nothing's changing, that I'm able to show people things that can help them improve their lives, that start from something as simple as having better habits when they write code. I mean, what really still amazes me is that a lot of these things come from these very simple starting points, these humble starting points. And once they learn, once a person learns the power of getting frequent feedback, not just frequent, but soon enough that they can do something with it, as opposed to waiting until it's too late, that they can start by making some small part of their daily life or their job a little bit nicer, but then that frees up time and energy for them to apply the same principle to something bigger. And then they make some bigger improvement in their lives, which then allows them to open up. Again, that creates more slack, more time, more available energy, and that this becomes a compounding effect. And 10 years later, I hear stories of people who have made radical changes to their lives, who are much happier with how they live. And it started with getting out of that feeling of being stuck in their job. I mean, that's exactly how I did it. Part of the reason we don't live in Toronto anymore has to do with extreme programming and theory of constraints. It seems strange, but it's true. And you'd be amazed at how much more slack you can create in your life when you start paying attention to how you actually spend your time and energy. That's value stream mapping. That's looking for bottlenecks. That's any of those things. these are not just ideas that we can apply to software. And so when I think this is where I would really like to go, is to bring the psychological elements of helping people together with these ideas from theory of constraints, from extreme programming, from from some of the people that I read growing up, like Tom DeMarco and Tim Lister and Jerry Weinberg. And by bringing these two kinds of ideas together, the sort of lightweight, agile, XP-ish stuff tends to be really good at giving people some inspiration and helping them see where to go. And the stuff from theory of constraints tends to help them feel like they're not just wandering in some hopeful direction, but that there's some reason to believe they're actually going to get there. It gives them it's what the Heath brothers call scripting the critical first steps. That they feel not only like there's a better place to go, but that they actually have a chance to start, that if they start walking, they'll actually be walking in the right direction.
JB, you sort of just gave a blueprint that looks very much like TameFlow. So we'll get back to that later, because many of those connections you were highlighting there were sort of inspiring a lot of my work. You mentioned before the Yahoo communities, the extreme programming communities, and so on. Well, TameFlow has a community. I'm showing it down there. It's community.tameflow.com. I don't think you have signed up there yet, but I do invite you to join. I think you would be a valuable contributor. But what is your idea now of a community of peers? What did you find in those Yahoo groups, and what would you like to see in such new communities?
Well, so this is the single biggest part is support, and of a very specific kind. It's one of the things that when I teach my introductory, the world's best introduction to test-driven development, one of the things that I take a very shuhari approach to practicing this stuff. And for those who don't know, that's really just sort of starting by following a recipe and then gradually reverse engineering wisdom, starting by following the recipe. And so there are many models that really amount to the same thing. It's very easy to write a book to help people start with the recipes, but how do you reverse engineer the wisdom? Not only is it not the kind of thing you can write a book about, really. You could write meta books about it, I guess. But for everybody experiences it differently. And that really is the central thing that I expect from these and find valuable in these communities. For programmers trying to use a complex technique like evolutionary design, the design part of test-driven development, they will relatively soon reach a point where their intuition tells them to move the design in this direction, but what their reading tells them to move, or what they're practicing tells them to move their design in this direction, and they don't match, and they don't know what to do in that situation. And that's really what I want these communities for, where I find them the most valuable, is to answer the questions, the rules tell me to do this, my gut tells me to do that. What does this mean? Does this mean the rules are wrong? Does this mean my gut is wrong? Do I need to unlearn something? This feels really uncomfortable. What do I do with this? How do I move forward? And the groups that I got to participate in at the beginning of my career were absolutely instrumental in helping me resolve those conflicts and helping me not only, make progress in whatever little programming problem I was dealing with at the moment, but to really help me understand more about the interplay between starting with a simple set of rules, like the act of reverse engineering the wisdom from those rules, of extrapolating wisdom from those rules, how it's natural to go through a period where all your energy is focused on following the rules. And then eventually the rules start to help you so much that you try to make rules for everything. And that works for a while until you realize that the world is too complex to be governed by this decision tree, and then you need some kind of heuristics that'll help you, navigate your way through. that like this curve has a name and people know about it and people have written books about it. And this is a natural way of learning, which then informed how I taught the topics that I taught to people and could warn them in advance. Say, look, you're not going to master test-driven development in 3 days, but what I can give you is this. And when you're ready to go further, this is where you need a community around you of people that you can trust so that you can ask them these questions and get answers from them. And if you don't have that, you're going to hit a ceiling in what you can learn.
You just used a few magic words there. TameFlow has this notion that one of the founding patterns is a community of trust. Mm-hmm. And that we work on a lot when we are actually using TameFlow, and even this online community wants to be something like that. And typically at this point, I would ask you, what is your community handle? But you'll still have to create that. Be quick there so you can register your Jbrains.
Yes,
word.
Nobody take Jbrains for me.
No, we'll reserve that for you. But just to remind people here that if they want to reach out to you, they will find all the contact information at www.jbrains.ca. That's Canada, not .com. C.ca. You mentioned something about the best TDD course. I'm not so sure that all people in the audience know what TDD is. They might have heard about it and heard all sorts of funny or strange things. But do you have like an elevator pitch, something you can show us and get everyone to understand what this really is about?
Well, so the short version of what TDD is it's a way of doing what I call evolutionary design. It's not my term, it's the term that I use. And evolutionary design is really just based on the idea that it's very hard to figure out how to design a complicated system before you start building it. We spent the 80s and 90s trying to do that, and it just didn't work.
In fact, many say TDD is test-driven design rather than development, right?
Yeah, that happened very early on in the community where people wondered whether we should change the name to test-driven design rather than test-driven development. Although it's maybe too long to talk about here, but I don't want to give people the impression that if they're not using this for evolutionary design, then they're doing it wrong. It's just that some people need to start with focusing on bugs, and other people can eventually get to the point where they're really doing evolutionary design. The idea that we don't have to make all the right design decisions up front. We can not only... So in the first real stage of changing how you design is the idea that you become comfortable changing your design decisions even after you've built the software. That writing code no longer feels like handcuffs. That it's more, as Ward Cunningham used to say, it's more like working clay. And if you change the composition of the clay a little bit, then you can make it soft and move it and reshape it and then let it harden. And if that doesn't work well, you still have some time to, again, soften it and reshape it, and off you go. So at first, evolutionary design is a way of being comfortable with the idea that I can change my design decisions. I'm not locked into a decision because I've already written code. But once you become comfortable with that, something magic happens, which is that you become much more comfortable deferring commitment to design decisions. That you don't need to figure things out early on. That you can, in essence, jump and the net will appear. And maybe it's better to say you can jump, and if you happen to fall and break your bones, you can just snap your fingers and heal quickly and try again. And say, oh, well, apparently I needed this. Like I wrote all this code and I tried to connect it to that thing and it doesn't connect because I missed something. No panic. If I refactor a little bit here and a little bit there, then the information I need will be where I need it to be, and then I can make that connection.
If most software like managers or business owners listen to you now, I think most will say, no, this is magic. This is not what I see. This is not what I see on the field.
This is the soft part of software.
Can you show us something?
I can show you something that will help a little bit with a very simple, small idea of how we can make decisions at the moment that we need to make them instead of making them up front. So if you'd like to switch over to full screen, let's try that out.
Yeah.
Okay, so here is a very simple teaching example that I use to help people really get started with test-first programming, even before they think about evolutionary design. We're going to add fractions. And the idea here is to show people what it's like to build this stuff up in tiny, tiny, tiny increments. Even though everyone in the audience, probably everyone in the audience, knows exactly how to do this. And if they don't remember the exact rules, then they can look them up online in 5 seconds. That's not the point. The point is to show that in a situation where you don't know what to do, it's possible to take small steps until you can see what you need to do and then do it at that moment. So here's a first test. All I've done so far is create 2 little fraction values that represent 0. And I'm trying to say, well, 0 plus 0 as an integer should be 0. That's how you can read that. So if you've never seen this format of a test before, try to let all the parentheses and the braces just fall into the background. And what you can read this as 0 plus 0 as an integer should be 0. And so you can see that the very first implementation of this looks pretty silly. So to the experienced programmers in the room, you're probably laughing right now or you're rolling your eyes. But one of the real powers about this is that I don't have to build very much. And already I can make this test pass. So let's run the test and see it pass. As long as we see nice green check marks here or this green tests passed in the corner, then we know everything is okay. So this is a very silly implementation of adding fractions. But if this is all you need, it's good enough to start. Let's now try to write a test. So I'm just going to duplicate the code, and I'm going to try to take a tiny step. Let's write a simple test that fails. So what happens if the number on the left is not 0? Let's make it 4. Well, 4 plus 0 should probably be 4. So now I've made the test say what I want. And if I run the test now, the new test fails. It's important to see the new test fail. That's that red here and the red in the bottom. If you write a new test and you never see it fail, then you don't know that it's actually testing anything important. So I always like to see that test fail at least once. But now the way I'm going to make this pass might look a little strange. So the first thing I'm going to notice is this is the first time that I've wanted code to represent multiple values. So actually I'm going to just temporarily undo the test that I just wrote, go back to the point where I have a green bar where all the tests are passing, because and assuming that I do that correctly, then the test will actually pass this time. I just want to get back to the point where the tests are passing so that I can make this 0 come from the outside instead of by magic. This 0, of course, should come from the value that we create inside the fraction. And now the test will fail because my plus function is returning this crazy value that has nothing to do with anything. Now, we have a saying in test-first programming. What's the simplest thing that could possibly work? You and I know how to add fractions, but pretend we didn't. Well, I know that the fraction object on the left-hand side is the right answer. So I'm just going to return this, which is Java's way of saying return the object on the left side. And that works because in our first test, this is always 0. Well, now, if I look at my second test, that will also pass because in the first test, this is 0. Pardon me. In the first test, this is 0. And in the second test, this is 4. I can ignore the value over here for now. I don't need it in order to compute the right answer. And so that is a step. Now, again, this is not how to add fractions. So the next thing we do is rewrite one more failing test. And our goal in writing this next failing test is to nudge us in the direction of doing what we want. Well, what happens if we have 0 plus something else, like, say, 7? Well, the result should be 7. That test will fail. And now here's where the magic starts to happen. Pretend that I have no idea how to do this. I can use a simple mechanical trick. I can make the new test pass by using this. If it's the old situation, do the old thing, else do the new thing. So in other words, if I can figure out what was true about all the old tests, all the old examples, then I could just say, well, in those cases, keep doing what you did before. I don't have to understand it yet. And in the new case, do the new thing. Well, what was true about the old cases? The old cases, the second value was 0. Fraction is not a nice name for that. I'm going to call it that because this and that go together. So if that is 0, then continue doing the old thing, which was just I don't even care what it is. Just do what you did before. If that value is 0, then just do what you were doing before. Otherwise, do the new thing. And the new thing is to return 7. Now I can try that. And that works. But that 7 really comes from magic. That 7 is really the second value, the value that's being passed in. Now let's look at what happened here real quick. This looks like a silly implementation of adding fractions, but really what's important here is that in order to make the next test pass, all I had to do was say, what was true about the old tests? What did they have in common? And what's different about the new tests? Well, if the integer value on the right-hand side, the second value, is 0, then I can just keep doing what I was doing before. The old way, which doesn't work for every situation, still works for those situations. And then I can figure out what's new about the new situation. Think about how much easier it is to think in this way compared to sitting there and every time you think you've figured out what the general algorithm is, somebody comes along and says, oh, but what about this case that we didn't think about before? It's enough to make you feel like you're never going to finish. Here, I can make progress at every step. In fact, let's just write one more test. What happens if neither value is 0? Okay, well, let's make the left one 3, let's make the right one 5, and the result should be 8. It's a good idea when you're writing tests, don't use the same test data over and over again. Okay, the test failed. Well, what was new about? So I want to keep doing this as long as the first value is 0. And otherwise, I need the answer to be, 8. Let's see, and this should be else if, pardon me. And that passes. But you and I know that 8 really means 3 plus 5. That's why we chose 8. And that 3 really means the first value, and 5 really means the second value. And so that, again, some experienced programmers looking at this simple problem might go, but to be frank, I find it really comforting in a very difficult situation to start by saying, okay, well, I know the right answer is 37. That 37 is really 25 plus 12, and 25 comes from this database over here, and 12 comes from this configuration file over there. I don't have to jump to the immediate correct answer right away. But by the same token, you saw how fast that was. It didn't really take that long for me to write 3 or 4 different versions of that line of code. So the steps, one of the principles of test-driven development, and indeed of any incremental way of working, and this goes back to theory of constraints, right? We can take a bunch of steps, and as long as those steps are correct, that will probably result in finishing sooner than it would take if we made a mistake. And now the last thing I want to show is, you know and I know that all 3 of these really kind of mean the same thing. Like if you look at the first part, if the second value is 0, then I don't need to add anything. This is effectively the same as doing this plus 0. Well, that means that this line of code will probably also work up here. Let's see if it does. Great. I have a hypothesis, green bar. I have a hypothesis also that this line of code will work in this case. So let's try that. Now that's convenient for one important reason. As any programmer will tell you, if you have an if statement and every branch of the if statement does exactly the same thing, then you no longer need an if statement. The reason that I tried to make every branch of the if statement look the same was so that I could remove the if statement and instead just have this nice general algorithm that works in all 3 cases. Point that way, the tests pass. So what did we just do here? The big thing that we did here, let me just switch over here. The big thing that we did here was that we were able to incrementally build from special cases that were simpler to build. And we could figure out how to generalize towards the general solution, one step at a time. The code worked at every step of the way. As soon as I had tests passing, they stayed passing, which means that as I'm adding more code, I'm building on a foundation that works. And I don't have to see the general algorithm from far away. I can start with some special cases that happen to work by making convenient assumptions. One of them assumed that the second value was 0. The other assumed that the first value was 0. What that allows me to do is to sneak up on the problem, to sneak up on the solution, I should say, to solve the problem a bit at a time, to add complications one at a time. And then as I see the patterns, as I start to see that this part here is a generalization of that part, and if I just make one little change, this more general algorithm will work for both cases. Now I've simplified the code. That's that refactoring part of test-driven development, where you look at things that you now notice patterns that you didn't notice before. And you can figure out how to make similar parts of the code look so similar that you can collapse them into one. And that's really the magic of test-first programming, test-driven development, evolutionary design. I can build up the solution incrementally. I can work with confidence the whole way. I don't have to stress about understanding the general solution until I really need to get there. And there's a whole bunch of complicated things that you learn and that you practice, signals that help you see now is a good time to try to look for the general algorithm, or no, it's too early. Or, if you notice that your special cases have a bit of duplication in common, then that's something to look for and to try to pull that out. There's this wonderful thing that happens where I don't have to know what the final design of the solution will be. I can build it up and make progress as I go along, and I will learn what I need to learn when I need to learn it. And as I learn something new about how the code should be designed, I have the confidence to change it, because all these tests will start failing if I get anything wrong. And the more tests I have, the more confidence I can have that I'll detect when I make a mistake.
That's maybe one of the biggest positive benefits of TDD, that confidence of changing the code. While in lack of TDD, you never know what might be the hidden side effect. And I also like that part, which is explained very well, that you're sort of progressing by exception. Everything that worked, keep it working, and just add that little extra bit to capture the new knowledge we're trying to transform from idea into code. It's funny that in TameFlow we have this notion of management by exception, so sort of resonates. You want to focus your attention on where it matters, and this mechanism you're showing is a focusing.
We talked early in the XP community. We talked about there was a fad in the early 2000s about test-driven management, and at the time, I think a lot of people had the idea of the test part was the important part, was making things measurable and objective, and all those things that, again, we tried that in the 80s and 90s, and it has some benefits in some contexts, but maybe denies a little bit too much the complexity of real life. For me, the part of test-driven management that mattered was truly the, as you say, management by exception. It's the how do I detect that I'm getting something that isn't what I want? And how do I use that to figure out what might be missing or what might need to change? And when you practice test-driven development, the evolutionary design part of test-driven development is where you learn patterns in how to improve the design of the system even before you know what a perfect design of the system would be. That you can always move the design in the direction of being better, and then you wake up one morning and realize magically that you ended up in this wonderful place. Or even better, maybe more importantly, you realize that for this project, for this code base, for these conditions, we didn't actually need to go all the way to the promised land. That going 30% of the way, 40% of the way sufficed. Maybe the single most important benefit of writing the tests first, not just writing tests at all, but writing the tests first, is so that the programmer will know when to stop. When the bar turns green, when the tests are passing, then it's time for the programmer to stop. And if you can't think of another failing test, then there's no need to go further. And that, to me, I think is one of the biggest parts. To stop programmers already know how to write too much code. We need to train them to write just enough.
I know you wanted to ask me a question here, so I prepared something. But what was it you wanted to ask me?
Well, so since I really don't know TameFlow well, but in the little bit that I've been able to understand so far, it feels very much like there's a strong connection between TameFlow and eXtreme programming. Now, I'm an old XP guy, so I have a vested interest in showing people how all the new ideas today are really just an evolution of eXtreme programming, and that's what we meant all along. So I'm curious, are there aspects of TameFlow that you would think of as some kind of a natural evolution from the ideas, either a refinement of eXtreme programming or a generalization or a specialization? Or are there, and so what would you say maybe comes from there and what really comes from outside?
Well, definitely, I think that my personal experience with XP has influenced my thinking, my way of looking at problems very, very much, and certainly left like sort of imprinting. So there has been an influence. Maybe it was not explicit and direct and deliberate, but like the philosophy, the way of thinking about things is there. And let me show you, because I have prepared my usual Miro board. And if you haven't seen my previous campfires, now this is the most entertaining moment, because this is where I can show the world how much I can fiddle about with a stylus and a tablet. So let me, now we are running short of time, but I think we can take another 10 minutes maybe, and let me talk about this, because I think it's a very interesting topic. Now, first of all, XP comes with a number of values. Now, TameFlow in and by itself does not refer to values. In fact, I'm very explicit about that the values have to come from the people in the organization. So we will not try to impose that. But XP has some very nice values: simplicity, communication, feedback, respect, and courage. And if we are into theory of constraints, we know that Goldratt came up with this idea of inherent simplicity, which is basically the focusing power of the constraints. If you have a gazillion things going on in your company, well, find that one thing that governs all of them and focus on that. That's a really simplifying thing to look at. Now, communication. Well, we have a process which is called the full kitting process, and it's really, apart from the technical aspects of preparing work, it is really a moment where the engineering side has deep conversations with the business side. And we know that in XP, we need to have like the customer being part of the team. And of course, that is an ideal situation. But when you are in large organizations where the customer might be on the other end of the globe in another organization, that might be a hard thing to do. So we try to formalize that face-to-face element, or that moment of communication, and that is the full kitting process. Now, between communication and feedback, now I mentioned before the management by exception. Well, that's clearly there. It's a way to raise awareness of things that are not working. And what you do when things do not work, you have to communicate. You have to discuss about them. So it is that element. Feedback then becomes this moment where people are talking. So the respect for people becomes essential, and we capture that with all the psychological elements of TameFlow. We strongly believe, like Goldratt was saying, it's one of the 4 pillars of TOC, that people are good. So if you have that predisposition of looking at people as fundamentally good, it's easier to respect them than if you have like the opposite predisposition, thinking that everyone is bad. We apply the evaporating cloud. If you have a shared goal, as we have in a company, then every conflict can be removed. This is another pillar of Goldratt. We do resort to the core protocols, which are like a shortcut to create very good psychological environments where there is a lot of communication and respect. Courage. One of the founding patterns is inspired leadership. Note well, it's not inspiring. I always highlight this point. It's inspired leadership. So a leader that believes in what are his own like values and principles and is able to transmit them. Courage is what you have when you exercise delegation. You need to have the courage to let go, not to micromanage. And when that comes about, then you're also exposing yourself to vulnerability, and you need to trust. That's you build the community of trust. So even though TameFlow is and will never be expressed in terms of values, if you reason about what happened or what are the values of XP, you clearly can see some of these correspondences. Now, what else do we have? One which is always a huge topic where there are lots of interpretations, the system metaphor. Now, TameFlow is not developing systems. It's working with organizations, but we do have some narratives that are there to give like an overarching common shared picture and image of what is going on. We have, of course, the story of Herbie, the scout. We have the patient in the hospital. I don't go into the details because then it would take too long, but I'm just mentioning them. We have the 3Js, the story of the jungle, the jeep, and the journey. And we have the story of the McDonald's tray. So these are narratives that you can like tell the story the first time you introduce the concept. And then every time there is a problem, you remind people, but do you remember the story of Herbie, what happened there at step number 3? And it's this repeating the story that gives that metaphoric value. What else do we have in XP that might be of interest or like reminiscent of things in TameFlow? The very important thing with sustainable pace. Well, you will reach a sustainable pace if you limit work in process, and we do that in the most TOC kind of way by using the drop buffer rope scheduling mechanism. What does this give you? Well, it allows you to uncover the excessive capacity, which is what you need to support Slack. And sustainable pace is that. It is allowing for Slack. Release planning. Well, in TameFlow, a release corresponds more or less to what we call a move. It's a minimal outcome value effort. It's a packaging of work that you want to do with a minimal effort, and you want to reach an outcome or a financial value. But the release planning activity as such is the portfolio level full kitting. Likewise, we have iteration planning, and that corresponds to the team level full kitting. Now on to, well, what I would say is really the favorite one of all this exercise of mapping to XP: refactor mercilessly and fix XP. Now, this idea of tinkering with the code and changing so it has a simpler design and evolution design, as you say, is like intrinsic in TameFlow. TameFlow is based on patterns, even though you might see that we have written a lot about Kanban, about TOC, and it might appear as a derivative of those schools of thought. The foundation of TameFlow is entirely based in patterns. And you know certainly the connection between refactoring and patterns, refactoring to patterns, designing according patterns. So you have this notion of keeping the design as simple as possible. And the other week or 2 or 3 weeks ago, we had Sandeep Joshi from Singapore on the Campfire, and he said, I think the most incredible description of TameFlow. He said it's simple and beautiful. That's like you would talk about a nice piece of code. So what does this mean? Well, fix XP means that you are fixing extreme programming when it's not working. You're open to change. And in TameFlow, we have the same thing. We are there continuously reconceiving itself. And I think this is very, very, very different from Scrum. Scrum has the Scrum guide, and God forbid that you even think to change it. It's the rule, and there is no evolution possible. It has to be like that. Okay, this would open up a huge discussion, but it shows a fundamental difference between extreme programming and Scrum. Extreme programming is open to evolution. Scrum is simply not. It's fixed in the book, in the guide. Some more things, and we're running short of time, but I'm almost done here. We have the notion of collective code ownership. Well, in TameFlow, this corresponds to the shared mental models. I like McCarthy's definition of software for your head. We work a lot with the mental models. The narratives we said before are there to put in the minds of everyone that there are some models, some ways to perform decision making that we should all be able to refer to. So it's the sharing of these models and also the evolution, the collective intelligence that will allow you to bring them forward. We have project velocity that naturally corresponds to operational throughput. We have the notion of move people around. Well, this is clearly the point from TameFlow's perspective when you have a Herbie and you use your excess capacity to help Herbie. So you have to go there, and if you don't know what Herbie is doing, you have to learn. So it is that transference of knowledge from one person to the other because you're working together. So it's the swarming part of when things get stuck. You have the stand-up meetings. Well, in TameFlow, we do stand-ups, but they are very different. They are not on a cadence. They are on the basis of those execution signals we mentioned before that allow the managed by exception. And we also have like ad hoc stand-ups. When something is not working, we call for a meeting. And on the contrary, if we have no reason to be preoccupied, if everything is fine, why have a meeting? Everything is fine. As Daniel loves to say, let people work. So I think these are the things that come or that can be like related to the extreme programming mindset. And then you also ask them what is not from extreme programming. And there I would just summarily say we do take a lot of inspiration from many other schools of thoughts. So we have, I already mentioned the patterns, pattern languages, pattern theory. On the psychological point, the core protocols, nonviolent communication, Bob Marshall's right shifting, Laloux's model. We mentioned the Kanban method, the real Kanban of Toyota, Lean, Discovery Kanban of Patrick Stayert, Popcorn Flow, discovery-driven planning, of course, TOC systems thinking, throughput accounting, beyond budgeting, and incremental funding. So these are all contributors to the ideas, to the mental models that we use in TameFlow. And we are really running beyond the time limit. So I will end this here and maybe just ask you, what's any comments about this?
Well, so a lot of the stuff there are a couple of items that I'm not as familiar with, but I see a lot of those as evolutions of XP. So if you use, and I sometimes I worry that when I say that, people think that I think XP is all there is. More what I mean to say is people have this picture of extreme programming as being quite rigid, whereas I think that they're just a bunch of rules to help you get started, to show you what you might wish to pay attention to, what might be important for you to pay attention to, and that if you start, then what you learn from the rules, you then use. You remember that they did just say they're just rules. As you say, you can use XP to fix itself. A lot of the things that people talk about now as being new or replacements for Scrum or XP or any of the other earlier Agile methods, I see them as evolutions of extreme programming, just the same way that I can look out the window and point to a bird and say, that's a dinosaur.
Well, thank you for that perspective. I sort of like share that because I see many of these parallels, and I think TameFlow is actually on an instance that is evolved, that has evolved from those notions. It's no longer about coding, but it's still about software of the mind of people that have to come together as a social body of individuals that communicate and interact in order to make decisions and reach a shared common goal. We are way out of time, Mr. Jbrains. So I thank you so much for having been a guest here and teaching us a bit about TDD and bringing back great memories about extreme programming. Is there any final words you'd like to say?
Yes. One of the aspects that you mentioned, the TameFlow, is the principle that people are good. This is maybe one of the nicest, most important aspects of evolutionary design over time, and that is that as the programmers learn how to design better, we can trust them more, and you no longer have to be limited to your architects, your senior programmers no longer have to be the bottleneck. It does allow you to feel comfortable delegating design decisions downwards to the people who know best what to do. And wow, does throughput ever go way up when you reach that point? It takes a while to get there, but it makes a big difference.
Well, that was a wonderful conclusion. Thank you so much. And to the audience, let's see, do we have any comments here? Well, we have GTNet. Thank you, JB and Steve. Well, thank you for being there and listening to us, even if we ran out of time. Okay, so thank you, audience. Thank you, JB, and we will be back with a campfire sometime soon again. Goodbye.